Let's begin. Today's June 27th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 3, 7, 9, 11, 18, and 22. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, criteria card C. On the bottom row, we've got criteria card D, criteria card E, and criteria card F. Criteria card A looks at the middle digit, square digit, and we'll be comparing it to the number 3. So should the value of square be less than 3, should it be equal to 3, or should it be greater than 3? Criteria card B looks at the last digit, the circle digit, and the Turing machine will let us know whether its value should be an even digit or an odd digit. Criteria card C looks at the 3-digit solution, and the Turing machine will let us know how many of those digits are 3. Will there be no 3s? Will there be a single 3? Perhaps 2, maybe even all 3 will be 3. Criteria card D looks at the first 2 digits, the triangle and square, and compares them. So should the value of triangle be less than square? Should they be equal, or should triangle be greater than square? Criteria card E will look at the 3 digits, triangle, square, circle, and will be adding their digits and giving us a sum total. And the Turing machine will let us know the sum should be equal to an even quantity, or otherwise, will it be equal to an odd quantity? And finally, criteria card F looks at our 3-digit solution and will let us know a little bit about the order of the numbers. So should the numbers be in an ascending order, meaning that they're increasing, as in the example 135, or are they decreasing, or basically descending, be in descending order, as in the example 421, or perhaps they have no order, such as the example 231. Now the reason it's considered to have no order is, if you notice, it goes from 2 to 3, so it increases, but then it falls down to 1, so it decreases. So it's that shift from increase to decreasing, or vice versa, that is one way to define the 3-digit solution to have no order. Now remember, the objective of today's puzzle is we're trying to find this unique code that abides by all 6 criteria cards. And we're going to begin by using the initial proposal of 314. So the first thing I want to do is I want to test criteria card B. I want to find out if that last digit is an even or an odd. So I'm going to test B. Okay, so the Turing machine does not approve of my proposal. Notice that in my proposal, I chose an even 4 for circle. Since the Turing machine does not approve of that, it's basically telling me that circle should be an odd digit. So that's what I'm going to write in my notes in section B, that circle is an odd digit. And because it is odd, that means I will be crossing out all of the evens. So I'll be crossing out 2 and 4. Okay, so the next thing I want to test is, notice that criteria card E tells me something about the overall evenness or oddness of the 3 digits concerning their sum. So let me go ahead and test criteria card E. Okay, so the Turing machine does approve that their sum, well, in my case, I have a proposal of 314. Its sum is 3 plus 1 is 4, 4 plus 4 is 8. So my proposal sum is even. The Turing machine agrees with that. So let me go ahead and write that down in my notes for section E. That triangle plus square plus circle should be an even quantity. And because it is even, it does tell us something about triangle and square. So since the overall sum is even, notice that we already established that circle had to be odd. So that means that among triangle or square, one of them has to be an odd. And the reason is, if one of them's an odd and it gets added to circle, which is also odd, well, those two odds give us an even, and then the other one, triangle or square, must be an even. So basically, triangle and square are one is even and the other is odd. So let me see if I can eloquently write that down. So let me see. So I'm going to say triangle. I'll say among triangle and square, I'll say one is even, the other is odd. So let's see. One is even, the other is odd. So let me go ahead and center it a little bit more. But yeah, so again, we do need one of them to be an odd, so that when it's added to circle, that sum is even, and then the other one being even will give us that overall sum to be even. So we just have to keep that in mind. We don't know which one is which, but we do know we have an odd and an even among the first two. Okay, so we have square. We could test square for being less than or equal to, less than, greater than, or equal to 3. But since we don't know if that's the even or the odd, maybe we'll just wait for the next round. And similarly for 3, well, we do have two odds. Even though I do have a 3, that might help. But I think what I'll test is criteria card D to see, because we do know one's even, one's odd. Maybe that will give us an upper hand going into round 2. So let me go ahead and test criteria card D. Okay, so the Turing Machine does not approve of what I've chose for triangle and square. Notice that my triangle is greater than my square value. The Turing Machine does not approve of that. And also recall that we are dealing with an odd and an even, so they can't be equal either. So in fact, I think it's safe to say that triangle has to be less than square. And so let me go ahead and write that down in my notes here, that triangle must be less than square. So what does that mean? If triangle is less than square, that means that triangle cannot be a 5. Because if triangle were 5 and it's supposed to be smaller than square, what would square be? Can't happen. And similarly, square also can't be 1, because if it's supposed to be bigger, what would triangle be? Okay. Well, that does it for this round. We've already done our 3 Turing tests, so we're going to proceed into the phase where we're going to discuss and think about how to construct a good second round proposal. So let's think about this. Again, we didn't test criteria card A, which tells us a little bit more about square. We also don't know the number of 3s or their ordering. Since one of them is odd, just curious, we do have the square equals 3, which would be helpful if it could be square. So what would that do? And well, if we can establish square to be 3, and we know triangle would then be even, well, the only even that's less than 3 is 2. We'd have 2, 3, and then depending on the ordering, 2, 3, there's no indication that we'd have pairs or duplicate digits like a 3, 3. So it's either going to be increasing 2, 3, 5 or no order in 2, 3, 1. That's if it's a 3. And of course, yeah, there is a criteria card C that will let us know. So let's see. Obviously, we can't have 3 3s because we do have an even. If we have 2 3s, like 3 3, well, it can't be 3 3 because they can't be equal. Okay, so then that would mean that either if there are duplicate or double 3s, they'd have to be triangle and circle, and then potentially square could be 5, and that would be no order because it goes from 3 to 5 and then back to 3. Oh wait, what am I saying? I need an even. So okay, so no, we can't have 3 5. So the middle is odd. This has to be even. So okay, so if this is odd and it's 5, I don't think that would work because both 2 and 4 are less than 5. So if it is odd, it can't be the 5. It would have to be a 3. What about even? If square is even, it could be less than 3. That would force triangle to be 1. So 1, 2. If there are no 3s, then there's no way to pick. Well, no, I guess you could say it could be 1, 2, 1 or 1, 2, 5. Is that right? No, actually, oh yeah, because of the ordering. Yeah, you could say 1, 2, 1 or 1, 2, 5 with no 3. Yeah, I'm not sure. But I am liking the fact that that is equal to 3. Okay, I think I'm just going to go with that. So if it's 3, it would force the triangle to be 2, and then potentially no order would be a 1. So let me go with 2, 3, 1 and see where that takes us. Okay, so the whole purpose was to test A. So let's go ahead and test A. Okay, so yes, square is equal to 3. And that was criteria card A. So let's go ahead, type that up. Square does equal 3. So that means we can cross out a whole lot of stuff. Okay, and because, why does that look off center? Okay, and because it is equal to 3 and we're dealing with an even, that means that, yeah, triangle has to be the 2. So I'm bringing this over and then crossing out everything after 2. Okay, and that was, yeah, that was just for criteria card A. Okay. Well, I guess we don't know the number of 3s. 2, 3, 3, 231, 235. Is there anything? Yeah, so those are both odd, so the sum's going to be even. We've already taken care of criteria card D and E. So it has to do with order. So let's see, would finding out the order of things be better than getting the number of threes? I think I'm going to test the order first and see if that helps out. So let me test criteria card F. Okay, so it approves of the order 231. Notice that in my proposal I am going, it's increasing and then decreasing, so that's no order. So type of no order. So that would mean that it can't be a 5. Can't be a 5 because that would be increasing 2, 3, then 5. So the question then becomes, and so this does bring to light, I know when I introduced criteria card F, I specifically just stated that no order is when you increase and decreasing. Technically there's an alternative possibility. If it's 2, 3, 3, that's also considered no order because it doesn't increase or decrease by going from 3 to 3. So whenever you have consecutive digits, as in triangle square being the same or square circle being the same, those actually constitute no order because it's not either increasing or decreasing. So that's really an alternative that I didn't mention, but that's because I don't normally state it because the example that they offer is just increasing and decreasing. It would probably would have been helpful if they also included this other condition where, again, if 2 consecutive digits are identical, that's considered no order. So actually, this did not help me eliminate 2 possibilities. So 233 and 231 are both no order. And so, yeah, criteria card C will kind of break the tie. Are there 2 2s or just a single one? And there's really no way to deduce it. I don't think there's anything that prevents it from having a duplicate. I know there's typically a verifier that does that for us, but for all intents and purposes, I don't think you can just, there are multiple ways that you can have duplicates. So yeah, I'm gonna have to test C to break the tie, so to speak. And so yeah, so in my case, I only had the single 3, and so that's the answer. So for criteria card C, I'll just state there is a single 3. Okay. And yeah, and of course it can't be the circle because then what would square be? So obviously the square remains 3, and it's the 3 for circle that would get crossed out. And so that looks to be the solution, 2, 3, 1. And so quickly to review, is the middle digit square 3? Yes, it is. Is circle an odd? Yes, it's a 1. Is there a single 3? There is. Is the first digit smaller than the second? It is. 2 is less than 3. Are the sum even? Yes. When you add 2, 3, and 1, you get 6. That's an even. We just deduced that among triangle and square, 1's even, 1's odd. That's true. And there is no order. It does increase to 3 and then it decreases to 1. So that looks like it's going to be, well, it looks correct. So let's just confirm, and then we'll do the Turing test to see if did we beat the Turing machine or not. So, okay, yeah, so that's great. So what do we test? So we did BDE first and the first two were wrong, and then all the other 3 criteria cards were tested and they were correct. So B, D were incorrect. So B, D, E, and then in the second round we tested all the remaining criteria cards A, C, and F. And typically if we matched it, okay, so in this case we answered each one once, or queried once, but the Turing machine actually took 7 queries to get the same result in 3 rounds. So we beat it by 1. So I think really what helped out was this equal 3, because that guaranteed the triangle. And although it took us, I guess, 2 steps to figure out, what circle was, I don't think it was avoidable. So I think, it was a great solve. So if you did notice anything, please do add something to the comments. If you liked it, give it a thumbs up. And if you don't want to miss any future videos, please do hit subscribe and you'll be notified of the next available video. Well, until next time, have a great one.